All right, you guys, so we are getting started with this material. Be here soon, okay? This is just, if I'm late. Anyway, so this is the material that you actually covered a little bit with the teaching demo, but I know it wasn't super clear for all of you, so I do want to cover it a little bit more. All right, so concentration, we say, is looking at like the amount of solute dissolved in a solution. Okay, the amount of solute dissolved in a solution. Okay, and so then we have two different like adjectives that we use to describe solutions based on that amount. So we can say dilute or concentrated. And again, these words are referring to how much solute is in there. So a dilute solution is considered a weak solution. And it's going to have a small amount of solute, where a concentrated solution is considered a strong solution and has a large amount of solute. And so it's like even with, Gatorade powder, right? Do you use it all that powder, which is your solute, and it's very flavorful? Or if you're like me, you may only use half of it. So I'm using a small amount of solute, and so that would be considered dilute. Okay, so those are the adjectives that we have in play here. In that lesson, she talked about two different units that are ways to measure concentration. There's actually more, but these are the two that we are going to be focusing on for this class, okay? Molarity, which as you see here has a capital M, that's not a typo, okay? And then molality, which has a lowercase m. Again, not a typo. And you can see both of these start with MOL, which hopefully makes you think of moles. Okay. And so both of these equations are going to be involving moles. We're going to break them down and look at each separately. Okay. So this is definitely going to be some math. So if you have your calculator, please take out your real calculator, not your phone. Because if you think about like on a quiz or a test, you're not using your phone, you're using your real calculator. And so we want to avoid those calculator errors moving forward. So take a beat, get out that calculator. All right, so then we have molarity, okay? So again, this is our first, and we're looking at solute. So one thing right off the bat that I want you to note is that we are dealing with moles up top. But if you think about in the lab, when we're measuring stuff out, or like how much is in those little Gatorade packets, we're talking about mass there. We're talking about grams. And so it's been a little while, so let's take a beat and remind ourselves. Okay, so we use molar mass to go between grams and moles, right? Like if you're starting with grams, then to turn it into moles, you're going to have grams on the bottom and 1 mole on top, right? And this is where that molar mass is going. And if you need a refresher there, molar mass, you are adding the atomic mass, right? Those are the little numbers on the periodic table. Okay, so adding the atomic mass from periodic table for the elements, right? Like if you had H2O, that's 2 hydrogens plus 1 oxygen. Okay, so I just wanted to have that little refresher in there to remind you that, like, yes, if you are given 12 grams and you need to turn it into moles, you're going to have that molar mass canceling on the diagonal, which will leave you with moles on top. Okay. Fortunately for us, for molarity, its symbol and unit are the same. So that's great. Okay. Big M, big M. So the three things that we have involved here, we have molarity, we have moles, and we have liters. And so we can actually do like the density triangle we learned last semester, which makes our lives so easy. Okay, we've got big M equals moles over liters. right? So these are the different parts of the equation right above. So as a reminder, the way these things work, okay, right? You cover up the one that you are solving for. So if you like were to put your finger over the M, then that would leave you with moles over liters. If you put your finger over moles, that leaves you with molarity times liters. And if you covered up the liters, that leaves you with moles over molarity, right? And so you can use this to solve for your unknown. You're always going to know 2 out of 3 of these things. So let's take a look. All right, it says calculate the molarity of a solution. All right, so there's one piece with 34.6 grams of sodium chloride. All right, there's a solute dissolved in 125 milliliters of solution. Well, there's our solution. Okay, so there's our 3 parts: molarity, solute, and solution. So I'm actually going to start at the bottom down here. Okay, molarity equals moles over liters. And so when we look at this, we have our volume in green and we have our solute here. But our solute is in grams and it needs to be in moles, and our solution is in milliliters and it needs to be in liters. So we need to do some conversions here. All right, so we have 34.6 grams of sodium chloride. All right, so remember, we need to turn that into moles, and to do that, we are dividing by its molar mass, okay? And so I'm gonna have grams down here, 1 mole on top, right? That's molar mass. So to get the number that's going right there, it's Na plus Cl. So 22.99 plus 35.45 gives us our molar mass of 58.44. Okay, and then to plug this into our calculator, we take grams divided by the 58.44 to give us 0.592 moles. Great, so now we have our moles of solute, so that was one part. Oops, wrong color. Go. And then our volume, we need to go ahead and get that into liters. So we take the 125 milliliters divided by 1,000 milliliters, and we get our 0.125 liters. Okay, so now we have both parts of what we need for the molarity equation. We have the 0.592 moles over 0.125 liters. Again, I'm just keeping the colors to help us keep track. So we have 0.592 divided by 0.125, and that's going to give us 4.74 big M molarity. That is our unit. Okay, so there we go for the first one. All right, for the next one, it says how many grams of magnesium oxide, okay, so that is a solute, are needed to make 225 milliliters of a 0.15 molar solution. Okay, so there's our 3 parts: solute, solution, molarity. Again, I'm going to start down at the bottom. Molarity equals moles over liters. And so if we think about what we know here, we know the molarity and we know the volume, but we don't know moles. And so if we go back to our little triangle and we were to cover up moles, right? So cover up moles. To get moles, you would take molarity times liters. All right, so that means moles equals molarity times liters. All right, so we need to take those 225 milliliters and turn them into liters. Some of us can do this in our head. That's great. If you just move the decimal 3 times and you know what's up, that's great. Go for it. Okay, so there's our liters. And then our molarity, well, awesome. It was given to us in the question. So we're just going to plug in those numbers. The molarity was 0.150, and the liters was the 0.225. And so when we plug that in, we're going to get 0.034. And then take a beat and think about what unit that number is coming out as. Okay, so remember, we just wrote the equation over here, and this pink was our unknown. Okay, so that unit is moles. Great. Then we go back to the question and think, wait, what did it say? It said how many grams. All right, so now we have moles of our solute. We need to turn this back into grams. And so we're gonna take this number now, whoop, and bring it up here. We're gonna take that 0.034 moles, and it's magnesium oxide. So just remember, magnesium is +2, oxygen is -2, so those charges just cancel. So we have MgO. And now when we look at this, I have moles on top, which means I have to have mole on the bottom. Again, train tracks, your units always, 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 always canceling on that diagonal. So we've got 1 mole on the bottom, and we're gonna have grams up top. Again, to get that number, we're taking 1 magnesium plus 1 oxygen, which was 24.31 plus 16.00. And so that's giving us 40.31 grams. So now in our calculator, we're going to take the 0.034, we're going to multiply it by the 40.13, and that gives us 1.37 grams. All right, so what I'd like you to do now, I've done 2 for you, is go ahead and pause and do this problem. And then when you're ready, you can look at the solution. All right, so here is the answer and the work to the problem. If you need to take a minute, go ahead and pause and look through it.